Okay, previously you have learned how to find equation of a straight line. So let me just write down first. Any equation of a straight line would normally be in the form of y equals to mx plus c. That is like how we name any straight lines. Alright. Now, previously we were given two coordinates and we were able to find the equation by first using the two coordinates to find the gradient. Now, in this question here, you will notice that in the entire question, there's only one coordinate that is given. So there is no way for you to just use this one because there is no other coordinate to help you. So in this case here, right, what they are actually trying to tell you is that you can actually sometimes borrow the gradient from another equation. And this is the equation. Okay, so let me just highlight this. Alright. So using this one here, we are going to find the gradient of this line. So we have 4x plus 2y equals to 5. And now a lot of students will just say that, oh, the gradient must be 4 since that's the number that is next to x. But if you look carefully here, remember, for our equation of a straight line, we can only have y. No 2y, no 3y, no half y or anything, it must be y. And if you look carefully here, there is actually 2y here. So what we will need to do first is that we will need to divide everything by 2. Y, so that will give us 2x plus y equals to 2.5. And we need to try to make y the subject on the left hand side. So in this case here, in order to get rid of the 2x, I'm going to do a balancing of minus 2x on both sides. So what I'm going to have is that y equals to negative 2x plus 2.5. Now, 5 divided by 2, you can leave it as a fraction or you can put it as 2.5. It is okay. Now, what I want to highlight here is that this negative 2 is now the gradient. And how do I know that? It's because it's in this form, y equals to mx plus c. So once y is made as the subject, whatever the coefficient of x is, then this will be the gradient. So for part 1, they actually ask you, find the gradient of this line. So the answer is, the gradient is negative 2. Alright? So let's look at the second question. They say that there's another line with the equation y equals mx plus c. So basically, they're just telling you that, hey, this is just the general form of any line, okay? It has the same gradient as our previous equation. And that's the reason why they actually help you to find the gradient first, which is negative 2. Remember? And they say that it passes through the point 3, 5. So let's backtrack a little. Remember, for any equation of a straight line, we have y equals mx plus c, correct? Since this new line has the same gradient as the previous one, I can replace the m with negative 2. So y equals to negative 2x plus c. Simply because they said that they share the same gradient, you see. So we have negative 2 as the gradient. Of course, we still need to find the plus c, correct? And to do that, like what we did previously, we will need to have a coordinate to help us. And the only coordinate that we actually have is here, 3, 5. So what we're going to do is that I'm going to write down here, sorry, erase that. Okay, so 3, 5, again, first value is x, second value is y. We're going to replace it here and here. So instead of writing y, I have 5. And instead of x, I have 3. So 5 equals to negative 2 times 3 is actually negative 6. And similarly, remember, we want to make c the subject because we want to find out the value of c. What we're going to do is that we're going to try to get rid of the minus 6 here by balancing. So plus 6 plus 6. So 5 plus 6 will give me 11. And this is the c value. So they asked us to find the value of c. So actually, this is our answer. But if we were to write out the full equation again, we will write it as y equals to negative 2 x plus 11. This is the gradient, and this is the y-intercept, which is the c value.